Hi everyone, so we're going to look at alcohols. It's the third homologous series that we are going to be studying, and alcohol is not a hydrocarbon, and so it does not contain only hydrogen and carbon. There is also oxygen in it. So there is an OH group in the structure. So that OH is actually the functional group. So functional group here is OH group, and all alcohols name end with ol. So then you'll have the name methanol, ethanol, propanol, butanol. Now, alcohols have the general formula CnH2n plus 1 OH. So just things to recap over here. It's from the alcohol homologous series. It has functional group OH. It has general formula CnH2n plus 1 OH, and it is not a hydrocarbon. So these are the main things to note here. So you're going to fill in the table. So make sure you write this in your copybook. So 1 carbon, meth, so methanol, formula CH3OH. So 1 carbon, so it has general formula CnH2n plus 1 OH. So if N is equal to 1, so then the formula will be CH, so 2 times 1 plus 1, 3 OH. So this is the formula CH3OH. And the displaced formula, you'll start with a C, fill in the 3 H's, and then OH, which is the functional group. Let's do for 2 carbons. So it will start with F. So ethanol. And it should have formula because N is equal to 2. So CnH2n plus. So if N is equal to 2, so C2, 2 times 2, 4 plus 1, 5 OH. So C2H5OH. So there is 2 carbon, so 1 carbon, 2 carbon. Let me put the H here. H, and then OH. Now you can start by drawing the carbon, then the OH, then the H. Up to you. So as long as the number of hydrogen is okay. Be careful, the oxygen can form only 2 bonds. 1 bond is with the H and 1 bond is with the C. So I don't want to see you drawing oxygen like this. Be careful, oxygen has only 2 bonds. Let's see, for 3 carbon, so N is equal to 3, so the name will start with prop, so you will have propanol, and the formula, so C3H, 2 times 3, 6 plus 1, C3, 7 OH. And for the structural formula, so let's draw the 3C. 1, 2, 3. Let's draw the OH at the end of the molecule, and then we fill up with H everywhere. So like this. Now you could also draw it like this. It's the same thing. And if you remember the term isomer, where you have molecules that have the same general formula, the same molecular formula, but the different structural formula, then you can position this OH at different places. So then you can have it on the first carbon or the second carbon. So it will still be the same thing, but with a different structural formula. So you could have the OH here, and then you fill up with the H. So this is an isomer of the alcohol. Okay. Let's see for 4 carbons. So it will start with but, so butanol, and it will be so C4, 2 times 4 8 plus 1 9 OH, and when you draw it, you will draw the 4 carbons 1 2 3 4, add the OH, and then fill up with hydrogen. Here you go. And for 5 carbon, it will start with pent, so it will be pentanol, and so C5, 5 times 2 10 plus 1 11 OH. I draw my 5 carbons, draw the OH, and then fill up with hydrogen. Make sure that all your carbon is forming 4 bonds because it has valency 4, all the hydrogen is forming only 1 bond because it has valency 1, and all the oxygen is forming 2 bonds because it has valency 2. State why alcohols are not hydrocarbons. I'll let you answer this. Now, manufacture of ethanol. Ethanol can be made by 2 processes. So either you have reaction with ethene and steam, or you have the fermentation of glucose. Let's start with the first one. So if you have ethene, so for this reaction, the conditions that you should know that 300 degrees Celsius, 70 atmosphere, and phosphoric acid catalyst. We already covered that in alkene section. So this is an addition reaction where the double bonds will open and the H and OH will add into it. So then you have water in the form of steam at very high temperature, so 300 degrees Celsius. It will be gaseous state, and the double bond will open, and on one point you will have OH and the other point you will have H, or you could interchange them. You could have OH here and H here, doesn't really matter, and the product is ethanol. So ethene plus steam will give you ethanol. If you start with propene, it will give you propanol. Butane will give you butanol, and so on. So this is the first reaction to give alcohol. So here we're looking at ethanol. So we'll start with ethene. Second reaction to get ethanol is by the fermentation of glucose. Those who do biology have come across this reaction. So yeast contain the enzyme zymase, which catalyzes the breakdown of sugar molecules, glucose, to form ethanol and carbon dioxide. This is the chemical equation. So here you have the glucose, C6H12O6, and glucose can be, so that's just basically sugar. So if you take sugar, you add yeast to it. So you have yeast. In the presence, this reaction will take place in the presence of yeast to give you ethanol and carbon dioxide. And what the yeast is actually doing here is called anaerobic respiration, which means that it is breaking down glucose in the absence of oxygen. So when you're doing the reaction, you have to make sure that there is no oxygen that is getting into the system, and it should be at 37 degrees Celsius. Now, yeast is an organism. It's a microorganism. So it's a living microorganism, and in the absence of oxygen, it will break down glucose into ethanol and carbon dioxide, and at the same time, it's going to get energy for itself. So here you have a rubber band and you have a delivery tube. So here this ensures that no oxygen gets in, and during that reaction here you will have ethanol, which is going to be produced in solution here, and the carbon dioxide will escape. And when you start to see the lime water turning milky, you know that carbon dioxide is being produced, which means that there's going to be ethanol in the flask. Now, if you want to isolate the ethanol, you can do distillation. So if you do fractional distillation, you will be able to isolate the ethanol from this mixture, this reaction mixture here. Now, there are a few things that need to be noted when carrying out this reaction. The rubber band should be tightly secured so that no oxygen gets in. If oxygen gets in, then the yeast is going to carry out aerobic respiration, which is respiration in the presence of oxygen. So this is going to make the rubber band will make the apparatus airtight so that fermentation takes place in the absence of oxygen. Lime water also prevents air from entering the apparatus because you have a gas that is produced. You need to allow the gas to escape because else the apparatus can crack or it can cause the rubber band to go out. So the gas is escaping, but here the gas is escaping, but there is no air that is getting in. So it ensures that gas is flowing in only one direction. Foam or froth is observed due to the formation of carbon dioxide. So there's a gas that is being produced, and the carbon dioxide turns milky. And the fermentation of sugars produces a solution of 15% alcohol content. So here you will only have 15%. If the percentage of alcohol goes beyond 15%, it will start killing the yeast. So as soon as it goes a little bit beyond 15%, the yeast starts to die, and you have a solution that is going to be a maximum of 15% ethanol mixture. So the yeast dies and the fermentation stops, and you obtain the ethanol by fractional distillation. So let's compare these two methods of making ethanol. One is by the fermentation and one is from the ethene and steam reaction. So this is fermentation and this is addition. Fermentation is a natural process, while addition reaction is a man-made process. So fermentation is very simple, where addition with steam and ethene is more complex. Here you have more specific reaction conditions. Remember the 300 degrees Celsius, the phosphoric acid catalyst, and the 7 atmospheric pressure. So it's more complex. Fermentation needs a lot of large tanks because you're going to have carbon dioxide that's going to be produced. You need to give the yeast space, else too much of yeast is going to be crammed in a small area, so they're going to die. But addition, you need small scale equipment because this is just taking place in a reaction mixture, and you're all the time and you're maintaining the conditions, so it's just going to keep on going. Fermentation uses batch process, so every time you are doing the reaction, the yeast will die, so you'll have to start all over again. But addition is a continuous process because you will be providing the same temperature, same pressure. Catalyst, when you add a small amount of catalyst, every time it's going to be regenerated, and you will still use the same catalyst. You don't need to add catalyst all the time, so you just need to add ethene to the reaction mixture. It is continuous, and here it's called a batch process because you have to remove the solution and add the yeast again and give it sugar again. Fermentation is a slow process, addition is a fast process. Ethanol, here you need to purify the ethanol by distillation, while here you get ethanol of high purity. And fermentation uses renewable resources, so you have sugar and you have yeast, which is a living organism. But here, for the addition reaction, you need to start with ethene, which is obtained from crude oil. So this is non-renewable resources. So that's for the comparison. And attempt a few questions that I've added. Thank you.